Example number 5. Test the convergence of the sequence 2 plus 0.1 raised to n. Okay. Now what is the sequence? The nth term of the sequence is 2 plus 0.1 raised to n. Here again what is n? N is vary from 1 to infinity. Okay. Now let's check the convergence of this sequence. Now what is an? An is nth number of term of the sequence. So an is 2 plus 0.1 raised to n. Now apply limit n tends to infinity on nth number of terms. So we get limit n tends to infinity 2 plus 0.1 raised to n. Okay. Now let's check what is the value of limit n tends to infinity 0.1 raised to n. Okay. As we know that what is the 0.1 raised to n. Okay. This is the sequence. Now let's check the term of this sequence. So first term is what? 0.1 for n equal to 1. What is the second term? Second term is 0.1 raised to square. What is the third term? Third term is 0.1 raised to 3. What is the fourth term? 0.1 raised to 4. Okay, and up to infinite number of terms this sequence contain. Now what is the value of first term? 0.1. After squaring what we get? 0.01. After cube 0.001. Now here 0. Raised to 4 means 0.0001 and so on. Okay. Now observe the pattern. As here n tends to infinity. Okay. N is 1, n is 2, n is 3, n is 4. As n tends to infinity. Now observe this pattern. 0.1, 0.01, 0.001, 0.0001 means this number approaches to which number? 0 number. Okay. So if n is very large, this number is possibly 0.000000001 and so on. Okay. Means this is the approximate number. Means as we move on infinity, this number approaches to 0 number. Okay. So what we conclude? Here we can say that now apply the limit. So limit n tends to infinity 0.1 raised to n is equal to what? This number approaches to 0. Okay. Now use this knowledge to evaluate this one. Here separate the limit. Limit n tends to infinity 2. Okay. So 2 remain as it is 2 plus limit n tends to infinity 0.1 raised to n. Okay. So from these what we conclude? This is 0. Okay. So since 0.1 raised to n tends to 0 as n tends to infinity, limit n tends to infinity 2 plus 0.1 raised to n is what? 2 plus 0. So answer is 2. Okay. So after evaluation of limit what we get? Answer is 2. Okay. So that's why what we conclude? Hence the sequence is convergent and this sequence converges to which number? 2. Okay. Because what is the value of the limit? The value of the limit is 2 and 2 is the finite number. Okay. So this sequence converges to 2. Okay. And this sequence is a convergent sequence. Example 6. Test the convergence of the sequence 2 raised to n. Okay. Now as per the definition, first, what is the nth number of term of the sequence? An is equal to 2 raised to n. Okay. Now apply limit n tends to infinity. So limit n tends to infinity an is equal to limit n tends to infinity 2 raised to n. Now let's check as n tends to infinity what is the value of 2 raised to n. Okay. Now 2 raised to n. Okay. Here what is n? N is vary from 1 to infinity. So now observe the pattern. The first term of the sequence is 2. Second is 2 square means 4. Next is 2 raised to 3 means 8. Then next is 2 raised to 4 means 16. then next is 32 and so on. Okay. Now observe the pattern or observe the terms of the sequence. As n increases, the term increases. Okay. So for very large n, what we can say that this pattern approaches to very large number. Okay. So this pattern approaches to what? Infinity. Okay. So here what is the limit n tends to infinity? 2 raised to n. This one is nothing but infinity. Okay. Since 2 raised to n tends to infinity, as n tends to infinity, hence the sequence is divergent sequence. Okay. Here we are getting the answer infinity. Okay. So as per the definition, if answer is either plus infinity or minus infinity, what we can say? The sequence is divergent sequence. Okay. So 2 raised to n is what? Divergent sequence. This example is same as the example what? E raised to n. Okay. That we discussed earlier. Here the value is 2. What is the value of E? E is nothing but approximate value of E is 2.71. Okay. So we can say that 2.71 raised to n. Okay. This sequence. Okay. Now we discussed that e raised to n is what? Divergent sequence. It approaches to infinity. So same way 2 raised to n is again what? Divergent sequence. Okay. Example 7. Test the convergence of the sequence 2 minus 1 raised to n. Okay. Now for this sequence, first of all, we need to check what is the value of minus 1 raised to n. Okay. So now first write the term of this sequence. Okay. Now here I am breaking the sequence in two parts. First sequence is a 2 and second is minus 1 raised to n. Okay. Now I am first observing for minus 1 raised to n. Now see here, when I put n equal to 1, the term is minus 1. Now put n equal to 2, so term is minus 1 raised to square. Put n equal to 3, minus 1 raised to 3. Put n equal to 4, minus 1 raised to 4. Okay, and so on. Now first value minus 1 as it is, minus 1 raised to 1. Okay, so minus 1 raised to 2, even power, so it become positive 1. Same way minus 1 raised to 3, odd power, so again we get minus 1 as it is. Minus 1 raised to 4, even power, so we get 1, and so on. Okay. So when we are putting here n, different value, here we are putting different value of n, what we get? Minus 1, 1, minus 1, 1, and so on. Okay. Now from this what we conclude? When n is what? Odd number. Here n is 1, n is 3, n is odd number. What is the value? Minus 1 raised to n is equal to minus 1. Okay. Minus 1 raised to n is equal to minus 1 for n is equal to odd. And second check here. This is the positive 1 here. Same way positive 1 here. So when we get positive 1 for n equal to 2, n equal to 4 and so on. Okay. So what we conclude? For n equal to even, minus 1 raised to n is equal to 1. Okay. So now use this knowledge. Here what is the an? Limit n tends to infinity an is equal to, now put this an term. So what we get? 2 minus is as it is. Okay. What is the minus 1 raised to n? When n is even, we get the plus 1 value. Okay, so put here 2 minus 1. So we get answer 1 when n is even. And when n is odd, what we get? 2 minus as it is, minus 1 raised to n is minus 1. Okay, so 2 minus minus plus 1. So 2 plus 1 equal to 3. Okay, so here what we get? Limit n tends to infinity an is equal to plus 1 for n is even and plus 3 for n is odd. Okay, so what we conclude? Here we get two different finite value of the limit. So as per the definition, what we conclude? hence the sequence oscillates and the sequence is divergent sequence. Okay, oscillatory sequence is nothing but the divergent sequence. Okay, it is not the convergent sequence. Means for divergent sequence and for oscillatory sequence, these two sequences do not approach to any finite number. Okay, so that's why oscillatory sequence is nothing but the, we can say that it is a divergent sequence. Okay, so here for very large value of n, for example, suppose one take 1 lakh value, and suppose one take, no, I am not interested to take 1 lakh value, I am interested in 1 lakh 1 value. Okay, so when 1 lakh is what? Even number. 1 lakh terms means n is what? Even number, and 1 lakh 1 means what is n? N is the odd term. Okay, so here as n tends to infinity, this sequence approaches to two values or fluctuates between two values 1 and 3. Okay, so that's why what we conclude, this sequence is oscillatory sequence.